Okay, so now we're going to look at example number 5, which talks about horizontal representative rectangles. So what that means is that we're going to be integrating kind of in terms of x, or excuse me, in terms of y instead of x, um, because our area is going to have lines that add up, that the lines are going to be horizontal. So we have our two functions. We've got x equals 3 minus y squared, and x equals y plus 1. So we want to just get an idea, again, what does this look like? So imagine you're just doing this sideways. So x equals 3 minus y squared is kind of what like y equals 3 minus x squared would look like. Why did I do that? Okay, so 3 minus x squared, or 3 minus y squared, is going to be kind of an inverted parabola. It's kind of sideways, when they call them the sleepy ones. So we've got this value of 3, and it goes down towards the negative x. So this is y, or excuse me, this is x equals 3 minus y squared. And then we have x equals y plus 1. So this is kind of like what the graph of y equals x plus 1 would look like, except we are moving in a little bit different direction. So this, you could switch this, and this would be kind of like y equals, you could solve this if you want to make this a little bit easier for yourself, especially lines work easier. This would be y equals x minus 1, if it helps you to draw this line a little bit better. So it looks something like this. So the area that's enclosed here is this. Now we're going to want to do this in with horizontal rectangles, because we can see that there are times when the top function of this area is both is the green, right? The green is on top and bottom. But if we look at it sideways, this way, we can see that the green is kind of always higher in terms of x. So kind of switch your perspective, kind of turn it a little bit, and you can see that if we were to think about this in terms of white rectangles, okay, that the green is always on top. So that's how we have to evaluate this. So we are going to integrate now that direction. Now we need to figure out where these intersection points occur. Now these intersection points are going to be based off of y and not x, because we're now going to be counting up this way. So we need to set these equal to each other, just like we had done before. So 3 minus y squared, we're going to set that equal to y plus 1, and then we solve. We can see that we're going to get y squared plus y minus 2 equals 0. Excuse me. Y squared plus y minus 2 equals 0. This is going to factor to make y plus 2 and y minus 1, which means that we're going to have y values of negative 2 and 1. So this value up here is y equals 1, and this is y equals negative 2. So we're integrating that way. We're counting from negative 2 to 1 in terms of y. So because the height of our graph is measured alongst the x-axis, and so we need to do everything, we need to use y to integrate, because we have our functions in terms of y at the top. So our area here is going to equal the definite integral from negative 2 to 1 of our green, which is the higher x values. So our green is 3 minus y squared. We subtract away our blue, which is the bottom one, which is going to be y plus 1, and with the dx here. So now we have this set up, we can go ahead and find our area. So I'm just going to simplify this a little. So we're going to get 3 minus y squared. We distribute the negative on the other on the blue function, so we're going to get negative y minus 1. This should be a dy too, sorry. dy. And we simplify this just a little bit more for ourselves. We'll have that this is going to be 2 minus y squared minus y. So now we can actually go ahead and integrate. So our integration is going to make 2y minus 1/3 y cubed minus 1/2 y squared. We're doing that from -2 to 1. So now we plug in our numbers. So we start off, we plug in 1. We're going to get 2 times 1 minus 1/3 times 1 cubed minus 1/2 times 1 squared. We're going to subtract away, plugging in -2. So we'll get 2 times -2 minus 1/3 times -2 cubed minus 1/2 times -2 squared. And then we can simplify. So this will be 2 times 1 is 2. This will be minus 1/3. This will be minus 1/2. We subtract away, this will be -4. We get -2 cubed is -8 times a -1/3 makes a positive 8/3. And then we have -2 squared is 4 times -1/2 makes -2. And now we're going to break this up. This will be 2 minus 1/3 minus 1/2. We then break apart this. We distribute our negative to each part. So the negative times -4 makes positive 4. Negative times 8/3 makes -8/3. And a negative times -2 makes a positive 2. We can then combine our like terms. This makes 8. Oops. We have the thirds here, which makes -9/3. And then we have our -1/2. Well, -9/3 is the same thing as 3. So this is going to be 8 minus 3 is 5. 5 minus 1/2. Again, we can think of this in terms of a fraction. So we'll get 5 times 2 is 10. Minus 1 times 1, which is 1, over 2, which makes 9/2. So dealing with y is the same, except we just have to think about things a little differently. We just have to make sure that we're using y now, because our area between the two curves, we only have the only function that the way that we look at it is that the x's are always greater in this area that for the green function than they are the blue function. So because the x's are always greater, we want to make sure that we use everything in terms of y so that we don't lose any of our area. And so we end up getting 9/2 for our answer.